Hello, my name is Alejandro Lopez, and today we're gonna find the area of a parallelogram of two vectors. Basically, the area of a parallelogram is the magnitude of vector u cross product of vector b. So the first thing we're gonna do is the cross product. We have the I component, the y component, and the k component. So you place the u first, 3, -1, and 5. And the b component, 2, -4, and 1. So if you want to find the I component in the cross product, you have to just take care of the y and the k. So -1 times 1, and then -4 times 5. And this is the I component. So the I component will be -1 times 1 is -1, and -4 times 5 is -20. So basically it will be 19. The y component, you cross the y component and you just multiply 3 times 1 minus 2 times k, 2 times 5, and this will be 3, -10 will be -7. And the k component, you just take care of y and j, I and j, then it will be 3 times -4 minus 2 times -1, and it will be -12 minus -2, and it will be -10. So we have the resultant vector. We only need to find the magnitude of it. So to find the magnitude, you only have to take the square of 19 plus the square of -7 plus the square of -10 and take a square root. So it will be 361 plus 49 plus 100 square root. So this will give us 510 to square root, and finally the area is the square root of 510 square units.
Hello, my name is Tarango, and I'm gonna teach you how to get the volume out of a parallelepiped form of 3 vectors. So we basically have to calculate the area of the base times the height, which would be kind of over here. So we have in this example these 3 vectors, u, v, and w. We're gonna get the value of the cross product from u and v. That would give us a vector, and then we scalar multiply with dot product with vector w. Okay, so for the cross product, we have to make this arrangement of the 2 vectors, and then for letter I, we have to multiply 1 times 1 minus 2 times 0. For letter J, we have to multiply 2 times 1 minus 0 times 0. And for letter K, we have to multiply 2 times 2 minus 0 times 1. So we solve the operations individually and we get this new vector, which we're going to multiply times vector w, which is this one, in order to get the scalar value of the vector of the parallelepiped.
Parallelepiped.
So we continue with this dot product, and we multiply i's times i's, which in this case is 0, and j's times j's, which is 2 times 1, and then k's times k's, which is 4 times 2. So here the i's got cancelled out with this 0. The j's, we will get 2, and since it's like j times j, this goes up to 1, so we just got these 2, and plus 8, and same story with the case. So the final volume of this figure is 10 units squared.
Okay, hello, my name is Alejandro. Now we're gonna convert rectangular coordinates to spherical coordinates. So in this case, we have a rectangular coordinate, x squared plus y squared plus z squared equals 16. So basically, in a spherical coordinates, x is equal to rho sine phi cosine of theta, y is rho sine phi sine theta, and z is rho cosine of phi. So we're gonna put these new values in the original formula. As you can see, is phi sine of phi cosine of theta squared, and we just put the values in the formula. Now we square all the values in there because it's x squared, so we squared it, and then we just factor it out. So rho squared sine square of phi is equal to sine squared plus cosine square of theta. In this case, this is an identity. That means that this is equal to 1. So we get rid of it. And then we just leave with rho squared cosine of phi equal 4 squared. So after doing that, we are just left with this rho squared sine square of phi plus rho squared cosine square of phi equal 4 squared. So just as before, we just left out rho square and leave this new identity sine square plus cosine square. So just as before, this turns out into 1, leaving us with rho square is equal to 4 square. So we just take care of the squares and leave us with rho equal to 4. And this means that it's a plane.
So now I'm gonna show you how to change from a rectangular equation to a cylindrical. We have this example, x squared plus y squared is equal to 16, and in cylindrical equations, x is equal to r cosine of theta, y is equal to r sine of theta, and z is equal to z. So we have this equation, we substitute for the values of x and y, c is just c, and we make it squared. Then we factorize r out, and since we're left with cosine of theta squared plus sine of theta squared, we use the identity, and this converts to 1. So we are just left with r times 1 plus z squared, and the r squared too, sorry, is equal to 4 squared. And our cylindrical equation is r squared plus z squared equals 4 squared.